subtracting mixed numbers, which again we've seen before. All we're going to be doing is, and we'll be using cycle method. Yeah, there's cycle method to change the mixed numbers into improper fractions. Now, I'm going to reiterate this, although I've said it many times, and I hope you understand I don't feel like I can say it too many times. But the denominator, when we change these mixed numbers into improper fractions, it does not change the denominator. Just like when we work our way from improper fractions to mixed numbers, it still doesn't change the denominator. It may change the denominator if we look to simplify. But in this process, the cycle method is really just finding a new numerator, but it will not change the denominator. So we've seen this slide before as well. First thing we're going to do is change all mixed numbers into improper fractions. After that, of course, operating includes steps of its own, such as making sure that the denominators are the same, which we may have to force them to be. And we had three methods to do that, right? We made lists, we did prime factorization, and we also multiplied the denominators by each other into the other fractions, which scales them accordingly, but forces the denominators to be the same. Then we perform the operation. Of course, today we're just looking at subtraction. And then after we find that improper fraction, we would be looking for any simplification that can be performed. If we miss it, then we should catch it in the final step of these, which is once we get that improper fraction simplified, we should change it back into a mixed number, and we do that with long division. But we should check the fraction part of the mixed number to see if it can be simplified in the end. So perform the indicated operation. Do not give your answer as an improper fraction. Give your answer as a mixed number or proper fraction in lowest terms. So with subtraction, it's common for us to find that we can run into difference that is already a proper fraction, which of course would mean that we would not need to change it back into a mixed number. So that would be pretty nice. But let's run through our steps here first. So in this problem, we got 13 and 5/8 minus 3 and 7/10. But like we said before, the first thing we're going to do is change these mixed numbers into improper fractions using cycle method. So I'm going to start with the 3 and 5/8 and cycle method it. When I use cycle method here to change the mixed number into an improper fraction, it will not change the denominator, right? But it will give us a new numerator. So I'm going to put the 8 there right now. Of course, if you wanted to now, you could put the 10 there. So what the heck? Yeah, let's go and put that in there. And cycle method. Well, that's the whole number. All right, yeah, let's make that 13 times 8. That would be far more accurate. Well, we don't have our 13 multiplication tables down, and we don't have the 8 multiplication tables down to 13. So let's do this with some stacked multiplication. So 8 times 3 is 24. We'll carry the 2, and then 8 times 1 is 8, but plus the 2 there makes that 10. So that would end up being 104 from just the multiplication part. Now, be careful not to forget about the addition part of the cycle method. So we do need to still add the 5 numerator to make that 4 plus 5 is 9. 0 and 1 makes that 109 eighths. There we go. That looks much better. All right, so I have 109 eighths minus something tenths, right? But we'll use cycle method on 3 and 7/10 in order to change it from a mixed number to an improper fraction as well. So that would be, and I think I'm seeing this one right now, 3 times 10 is 30. And then to finish off the cycle, we'll have to add the numerator 7 to make that 37. So the numerator of that second fraction is 37. Now, we see with just a little bit of analysis here that the denominators are not the same now, but they need to be in order for us to perform the operation of subtraction, just like we would need them to be the same with proper fractions. We need them to be the same with improper fractions as well. So I've got my two fraction lines with subtraction in between, and we are changing the denominators now. So I can't write the denominators in those fractions yet. We got to figure out what they will be. Well, first come, first serve then. Yeah, we'll multiply the denominators by each other, which means then I would take the 8 denominator here and multiply it by the 10 and 37 in the second fraction. Now, it's possible I may have multiplied the second fraction denominator in the first fraction, but it doesn't really matter when you do it as long as it gets done, right? And what do I see? In the denominator, first of all, I see I get this 80 right here. Turned out kind of weird, but 80 right there, okay? But I got to multiply the numerator as well, so we're going to need to do that. And no, I do not have my 8 multiplication tables up to 37, so let's go ahead and do 37 times 8. Stack. 8 times 7 is 56, carry the 5. 8 times 3 is 24, but plus the 5 there would make that 29. So the numerator is 296. The denominator is 80. And if we do this right, the first denominator should be 80 as well. So I've already written it in there in anticipation that we will end up with the same denominator. But let's find out just to make sure. So the 8 I would multiply by 10, which is 80, right? So that actually, that kind of completes that part of our objective to make the denominators the same. But if I do it to the denominator, I must also do it to the numerator as well. So that's 109 times 10. So I would make that 109, just tack a 0 on the end to make that 1090. So now my denominators are the same. We don't really care if the numerators are, but I am performing subtraction on this. So let's go ahead and show the next step here. And for me, that next step would be to make this all one fraction with a denominator of 80. We are performing the operation of subtraction, but what are we subtracting? Well, we're going to take 1090 and subtract the second numerator, which was 296. And it does need to be in this order, because remember, with subtraction and division, order does matter, right? Well, I can't do that in my head. If I could, I would probably be wrong. So I'm going to do this stack, right? This is subtraction right here that we're looking at. So we're going to subtract these. Now, the 0, I'm starting in the ones place value. I'd have to borrow 1 from the 9 to make that 8. 10 minus 6 is 4. Now I have 8 minus 9, so I'd have to borrow 1 from that 0. Of course, that means we'd have to go into the next place value to make that a 9. But now I have 18 minus 9 in my tens place value. 18 minus 9 is 9. Now we only have the hundreds place value, right? Because we pretty much borrowed from this one here. So that's really 9 minus 2, which is 7. So my new improper fraction has the same denominator of 80, but I now have a numerator of 794. Now it'd be nice if we were done, but we're not. We are not done. At this point, I would be looking for any simplification that can be performed on these, this numerator and denominator, 794 and 80. Now the first thing I notice is that both of the numbers are even. So I would probably look to divide by 2 right here. Some of you know, and I think you can, divide this by 4. But where I'm just going to proceed pretending like we did not know that, okay? So let's see what we get. First off, I'd have 80 divided by 2. Hope that's showing big enough on the screen. Looks pretty good. 2 goes into 80 4 times. 4 times 2 is 8. Subtract, and that zero's out, so we're going to drop the other 0. 2 goes into 0, well, 0 times. That gives me a new denominator of 40. But now I've got to divide 794 by 2 as well. 2 goes into 7 3 times. 3 times 2 is 6. Subtracting it 1, drop the 9 to make that 19. 2 goes into 19 9 times. 9 times 2 is 18. So I'll subtract that. 9 minus 8 is 1. Drop the 4 to make that 14. 2 goes into 14 7 times. So I end up with 397. Now I thought it would be divisible by 4. It's not. But we do have 397. So looking at this fraction here, I got 40 denominator, which is a little bit more easy to kind of think about divisibility rules with 40. So 40, of course, divisible by 2, but 397 is not because of the 7 in the ones place value. 40 is divisible by 10 and 5, but 397 don't have a 0 or 5 in the ones place value either. You could say 20, but that's related to the 2 and 10. So it looks like this would be fully simplified as an improper fraction. Now that was still a lot of work, but we're still not done. Okay, because remember, we want all our answers written in as a mixed number. Okay, so we're going to end up with something with some kind of fraction line, right, like this. And we'll have our whole value here. The denominator we know already. It's going to stay that denominator 40. But this long division will give us a new numerator and a new whole number. Right, so I'm going to do 397 divided by 40. Let's see what this gives us. Well, I'm not familiar with my 40 multiplication tables here. So I'd say, let's look at the multiples of 40, right? 40, 80, 120. Why am I not showing the addition? It's because I'm really just adding 4 to these numbers and then tacking a 0 on the end. 16, 20, so 200, 240, 280. I think I need some more as well. See if I can fit them. 320, 360, and then 400 would be the 10th multiple. So I got all 9 of the multiples of 40 that we will need, and it looks like we're going to need all 9 of them because 40 will not go into 3, it will not go into 39, but it will go into 397. It appears 9 times. 9 times 40, we got that multiple right there, 360. I need to subtract that out from the 397. 7 minus 0 is 7, 9 minus 6 is 3, and the 3's cancel out as a 0 there. So I got a remainder of 37. Let's go back up to our mixed number and then put these values in. So the quotient is 9. That's our whole number. And the remainder is 37, so that is the numerator. And again, the last thing we should do is check to see, well, can this fraction of this mixed number be simplified? And no, it cannot. 37 and 40 are not divisible by any of the same values. So that's just it right there, 9 and 37/40. Now this example is a little different. I think, well, I don't think we've seen it before, but I think we've seen something like it. The denominator is 9. Didn't we see a problem like that in the last section? In any case, I mean the process really is just going to end up being the same, but we're going to be able to skip one of the steps, which we'll show you. So first up, we're going to change these two mixed numbers into improper fractions, and we are using subtraction here. But cycle method, right? So 5 and 2/9, let's do that one first. Again, the denominator is not going to change. It'll still be a 9 denominator there. But I'll start with the 5 times 9, which is 45. And then we got to add the 2 numerator there, which makes that 47. So that's my numerator of that first fraction. 47/9 is the full fraction. Then we'll perform cycle method on the 3 and 7/9. So we start with 3 times 9, which is 27. And then add the numerator 7. That'd be 14, carry the 1. 1 plus 2 is 3, 34. And that gives us a new numerator of the second fraction of 34. Now, of course, the denominator stays the same, so I'm still showing a 9 right here. Now, like we saw in that last problem, at this point, we would be looking to force the denominators to be the same. However, they're already the same. I like these problems. I don't know. They almost make me feel good inside because they're so convenient, right? So let's go ahead and write this as a full fraction, but with one denominator, 9, and we are doing subtraction here. What are we subtracting? Well, we're going to take 47 and subtract 34. Like this, right? And whatever we get out of this, we'll still have a denominator of 9. But what is 47 minus 34? Let's find out. 7 minus 4 is 3. No need to borrow, but 4 minus 3 is 1. So I end up with 13/9. I look at this fraction and I see that it cannot be simplified. Right? 9 is divisible by 3, but 13 is not. So we go straight into our long division. 13 divided by 9. Well, 9 will go into 13 once. 1 times 9 is 9. And when I subtract this out, I get a remainder. It's really 13 minus 9 is 4. So let's put this into our final answer as a mixed number. The quotient was 1, the remainder is 4, and the denominator stays the same as 9. And yes, you should be checking just to make sure that the fractional part of this cannot be simplified. And yeah, 4 and 9 are not divisible by any of the same values, which means that is done. And yeah, it's kind of a lot to ask of math people to give us more problems like that, but here we go. We got another problem with unlike denominators. That's okay, because we still know the process. I mean, it takes longer, right? It's just, but it's still work that we know how to do, all right? So first up, let's go ahead and change the 4 and 3/8 into an improper fraction. So again, I wish I remembered to do this more often, but I like to kind of set this up first so I can kind of just fill in the blanks as we go, right? I know it's subtraction. I know I'm going to end up with 2 improper fractions, so no need for mixed numbers, right? And so I say, well, 4 times 8 in cycle method, that'd be 32. And then cycle up to the 3, that means we're going to add that 3 there. 2 plus 3 is 5, then just bring down the 3, makes that numerator 35. So I have now 35/8, but cycle method on the 3 and 1/3 as well. So 3 times 3, which is 9. And then cycle up to the 1 there, meaning we're going to add the 1 to make that 10. So that ends up being 10 in the numerator, 3 in the denominator. How did I know that's going to be 3 denominator? Because it just keeps the denominator that was with it already. So now I have 35/8 minus 10/3. So let's go ahead and use that method then. So I'll say we're going to take the 8 denominator and multiply it by 3. Now looking forward here, that's going to give me a new denominator of 24, which means if we looked at the second denominator, it also should end up being 24, right? Now, I don't know that for sure, but we should find that it is the same. Before I look at that, though, let's multiply the 35 by 3 in the numerator as well. So that would be 35 times 3. I'll try to move that over a little bit. 35 times 3. 3 times 5 is 15. Carry the 1. 3 times 3 is 9, but add the 1 makes that 10. So that's 105/24. Now, I feel like I haven't said this in a long time, but if I have, please forgive me because, I don't feel like I can say this too often. We've taken this number, 35/8, and we changed the way it looks, but we did not change its value. Just the same way that just going back here, just the same way that we did with 4 and 3/8. We changed the way that it looked into 35/8, but we actually did not change the value. That's kind of a key component in math. If you can figure out that you can change the way things look without changing the value, then you can, well, there's almost no limit in mathematics that you can do, all right? So we look at the 10/3, and I'd say, all right, got to multiply the 3 by 8, right? Well, 8 times 3 is 24. So that accomplishes this part of the objective, is to force the denominators to be the same. They are the same. But I need to multiply the 8 by the numerator as well, so that's 8 times 10, which is 80, right? Really, all I did was 8 times 1, which is 8, and then tack that 0 on the end. Seems like it was like that on that first problem. But, in any case, the denominators are the same, so we're going to keep it the same when we combine this into one fraction. We are subtracting here, but we're going to take 105 and subtract 80. Right, so let's see what we get from that. 105 minus 80. Yeah, I'm trying to color code these. I hope it's at least kind of helpful. 5 minus 0 is 5. 0 minus 8, I'd make that 10 minus 8, which is just 2. So that gives us 25 as our new numerator. Denominator, of course, stays the same as 24, but new numerator of 25. So now I have 25/24, and these are pretty close together, so I wouldn't anticipate that they could be simplified. Of course, 25 is divisible by only 5, whereas 24 is not. So that kind of solves that part of it for us. So I'm going to change this now into a mixed number. Right, we got the whole value here. The denominator is not going to change, so it'll still be in 24ths. And yes, some of you can do this in your head. Some of you cannot, and that's okay as well. So I'm going to show this using long division. So those of you that can do it in your head, just be careful because, we tend to make more mistakes than we would like sometimes. At least I do. I'm talking about myself, of course, when I do things in my head. So, 24 won't go into 2, but it will go into 25. I'm not even going to show the multiples for this because it only goes into 25 once. 1 times 24 is, 24. When I subtract that, it'll give me the remainder of 1. 5 minus 4 is 1. So the quotient there is 1, so that's my whole value. The remainder is 1, so that's the numerator of the fraction. And it looks like that 1 over 24 cannot be simplified. So that just is our final answer there, 1 and 1/24. Now, something that you should have noticed on this one is that there was no need for simplification at this point, whereas that first problem that we did, there was a need for some simplification at this point. It just varies. Sometimes you'll use this method and you do need to simplify the improper fraction, but like we've seen in this one, sometimes you won't, which is actually one of the reasons why I like this method of forcing the denominators to be the same, because there's always a possibility that you may not need to simplify in the end. And you would see as well, if you made a list of multiples of 8 and 3, that 24 was the lowest common multiple of the two. And again, I almost feel like I've hit the jackpot when I've done that, but it won't always come out that way, so do be careful. Here we got 6 3/4 minus 4 1/2. But before we do, let's go ahead and change these two fractions into, not fractions, these two mixed numbers into improper fractions. And of course, the denominators will stay the same as 4 and 2 when we do this. But we will find new numerators for the 2. So cycle method on 6 3/4. Start with 6 times 4, which is 24. Then I would add the 3 numerator to make that 4 plus 3 is 7, drop to 2, 27. So I have 27/4 in my first fraction. My second fraction, 4 1/2, so I got 4 times 2 first, which is 8, and then add the 1 numerator to make that 9. So that ends up being 9 over 2. Now I talked about this last time, and with just a little bit of analysis or patience even sometimes, is if you look at this one, we should see that 4 is a multiple of 2. In fact, it was the same number that was used on one of our previous examples. So I would look at this and say, well, look, we got a 4, which is a multiple of 2, right? So couldn't I just change the 2 denominator here into a 4? Well, yeah, of course I could. I can do anything I want. It's just, if I do it to that denominator, which is, I know I would need to multiply it by 2, right, to make it 4. And 2 times 2 is 4. If I do it to that denominator, I must also do it to the numerator. So that's 2 times 9, which is 18. So that's a new numerator. Now, the nice thing about this is I did not need to do anything to that first fraction. So it's still 27/4. But see now that the denominators are the same, which is really the main objective. And understand as well that some of you are thinking, I don't really like to do that in the beginning. That's okay. You could just say, well, 4 times 2 and 2 times 4, and you'd have common denominators as well. The key thing right here, though, is that if you use that method, you should end up with the same answer that we get no matter what. It's possible that you may have to simplify in the end. I don't really know. However, from this, of course, we can now start to subtract. The denominator is going to stay the same with the operation. But this is now looking at 27 minus 18. And again, some of you can do that in your head, but I'm going to just expand it here. So 27 minus 18. 7 minus 8, I'm going to borrow from that 2. Really, it's 17 minus 18, which is 9. 1 minus 1 is 0. So, a little bit more space. Uh, 27 minus 18, we see there is our new numerator of 9. The denominator stays the same, it's still 4. So that's 9/4, and I see, and I think we've even seen this fraction already, cannot be simplified. except that we can change it into a mixed number, which is what we want in this section. So let's do the long division, and yes, I know, I think I've done it already, but we're going to do it again. Maybe not. Maybe I haven't done 9/4. In any case, 9 divided by 4. Well, 4 will go into 9 2 times. 2 times 4 is 8, so I'm going to subtract that out, and that will be my remainder of 1. So the whole value, the quotient, there is 2. The denominator stays the same at 4, but my remainder is the new numerator of 1. So I have 2 and 1/4. Of course, 1/4 cannot be simplified, which means that's done. Here's another good one. 6 and 5/8 minus 4 and 2/5. Same process, though. I mean, for me, anyways. So I would look at 6 and 5/8 first, and let's go ahead and change that then into improper fraction. So yeah, we're going to end up with 2 fraction lines in the subtraction. I guess we'll just fill in values as we go. Again, I'm not changing the denominators, by the way. Let's see if I can do this right this time. We're not changing the denominators, right? So the first denominator is still going to be 8, and then the second denominator is still going to be 5. No problem. But let's go ahead and use some cycle method on 6 and 5/8 right here. So I start with 6 times 8. 6 times 8 is 48. Then add the numerator there, 5. So 8 plus 5 is 13. Carry the 1. 1 plus 4 is 5. So that's my new numerator of 53. So I now have 53/8. We got 4 and 2/5, but we got to use cycle method on it as well. So I'd start with 4 times 5, which is 20, and then add the 2 numerator to make that 22. So that then becomes 22/5. Now the denominators are not the same, which means we're going to need to force them to be the same before we can perform the operation of subtraction. Assuming you can still hear me, I'd say let's take the 8 and multiply it by 5, right? 8 times 5 is 40. So that's my new denominator right there. And yeah, we're going to take the 5 and multiply it by 8 to make that denominator 40. See how that, again, this is nice because it forces the denominators to be the same. But I got to change the numerators accordingly as well, so that I have to do 53 times 5 in that first numerator. 53 times 5. 5 times 3 is 15. Let's carry the 1. 5 times 5 is 25, but add the 1 makes it 26. So I end up with 265/40ths as my first fraction, And I got to multiply the 22 by 8 in the numerator as well. So 22 times 8. 8 times 2 is 16. Carry the 1. 8 times 2 is still 16, but add the 1 makes that 17. So 176/40ths as the second fraction right there. Well, now that the denominators are the same, we successfully forced the denominators to be the same. We're going to actually do the subtraction here. But what are we subtracting? Looks like it's 265 minus 176. So let's go and stack those and perform our subtraction here. 265 minus 176. And this will give us a new fraction. Of course, the denominator will still be 40, but let's see what we get. 5 minus 6, I'll have to borrow from the 6 there to make that 5. 15 minus 6 would be 9. 5 minus 7, I'll have to borrow from the 2 there to make it 15 minus 7. And I get 89 right there. So that's my difference, and that's my numerator, 89/40. Now just a quick look at this. I know 40 is divisible by 4, 2, 10, 5, and that's pretty much all we need. And 20 you could say, but 89 is actually not divisible by any of those, which means that this should be simplified. Now we're gonna change it into a mixed number anyways, so we may see that it can still be simplified, but it should be a little bit more clear in the mixed number. Now again, we did this, we used the method of multiplying the denominators by each other, and there was no need for simplification at the end. Again, that's every once in a while this will happen where we don't need that long long division to simplify those values. Of course, we still need long division to change this into a mixed number, though. So that would give me 89 divided by 40 here. Let's go ahead and list some multiples of 40. 40, 80, 120. That's all we should need. 40 will not go into 8, but it will go into 89. Looks like 2 times right there. 2 times 40 is 80. So when I subtract that out, I get a remainder of 9. And this sets us up for the mixed number with the denominator 40. The quotient is 2, so that's my whole value. And the remainder is 9. So I have 2 and 9/40. Again, just a quick look at 9/40. Yeah, 9 is divisible by 3, 40 is not. Boom, we're done. Now don't panic, even though we are subtracting with 3 numbers here, right? 7 minus 1/7, minus 1 and 5/7. The good news is that these final 2 fractions, at least, have the same denominator. So when we get to that point, um, that part of it should be at least convenient, you know. All right, well, let's look at this. Okay, now when we operate with these values like this, we're just going to focus on the first 2 numbers. So I'm going to split this up, and I'm pretty much not going to do anything right now with minus 1 and 5/7 right here. So I'm going to write it out over here. We'll come back to it though. Okay, so I'm going to do 7 minus 1/7 here, and whatever I get from that, I'm going to put that in to this space right here, which is why I put that space in there. Okay. So let's focus just on these first 2 subtractions. And it's important that you do start from and move from left to right. We're going to talk about that more in more detail later on. If we don't get around to it in this class, you will definitely talk about it in 950. So I'm going to write this out, 7 minus 1/7 first, right? Now, usually we would say, well, 7 once, right? So that we have fraction minus a fraction. And then we can force the 2 denominators to be the same. Now, since the denominator of the 7 is just a 1, I'm not going to change anything in the 1/7 right there, but I will scale the 7 once by, well, 7. 1 times 7 would make that 7, and now the denominators match. But I got to multiply by 7 in the numerator as well, which gives me a new numerator of 49. So that's 49/7 minus 1/7. And yes, the denominators are the same, just like we need them to be in order to perform this subtraction. Keeping the denominator the same, we now have 49 minus 1. Now you could stack this. I'm not going to. There is kind of an expectation at this point that you can do that, not just in your head, but even without stacking it, right? 49 minus 1 will just take us 1 lower into 48. So I now have 48/7. And again, this is, I'm going to keep that as an improper fraction back in the original problem, 48/7. You could change it back into a mixed number, but we're going to have to change this 1 and 5/7 into a improper fraction anyways. So doing that would kind of create a slight redundancy. I mean, you can just to see what it looks like, but we're going to be operating with the improper fraction anyways. So at this point now, I am going to take the 1 and 5/7 because we took the first 2 terms and made it just one individual fraction right here. But I need this mixed number to be an improper fraction. So I'll use cycle method on it, right? I probably should have given myself more space, but 1 times 7 first is 7. Finish the cycle and makes that plus 5 is 12. Right, so what do I got? First fraction didn't change. It's still 48/7. Second mixed number there did change the way it looks, but it did not change the value. It's just now shown as 12/7. So I now have 48/7 minus 12/7, and the denominators match on this now, just like we said it would, which just makes this convenient. And we can now subtract the 2 numerators there. We got 48 minus 12. Let's go and stack this and do the subtraction. 48 minus 12. And what do I get? 8 minus 2 is 6. 4 minus 1 is 3. 36. And this is still in sevenths, but now it's 36 sevenths. 36 sevenths. Well, that's pretty good. And the last thing we need on this is a mixed number. I don't think I can fit that as much as I wish I could. A little bit more space. That's going right with mixed numbers. This is going to equal a mixed number. Got my fraction line all ready to go, and the denominator will stay the same as the 7. Right? But we need to do, in long division, 36 divided by that 7. And let's see what we get from that. So 7 won't go into 3, but it will go into 36 5 times. 5 times 7 is 35. When I subtract this out, I get a remainder of 1. So that gives me the two other values that I need to put into my mixed number. The quotient is 5, so that's my whole value, and the remainder is 1, 5, and 1/7. Again, just a quick check on this. 1/7, of course, that cannot be simplified because one of the values is a 1, and we're done.